Questions 11 through 20 on the 2003 Grade 9 Pascal Math Contest. If x equals 2 and y equals -3 satisfy the equation 2x squared plus kxy equals 4, then the value of k is. So we have 2x squared plus kxy is equal to 4. So x is equal to 2 and y is -3, so just plug those numbers in. So 2 times 2 is 4, 4 times 2 is 8, and this becomes minus 6k is equal to 4. Bring the 4 over, put the minus 6k on the other side, so this becomes 4 is equal to 6k, and therefore k is equal to 4 over 6. In lowest terms, that would be 2 over 3. So 11, the answer is A. At a math conference, the following exchange rates are used. 1 calculator equals 100 rulers, 10 rulers equals 30 compasses, and 25 compasses equals 50 protractors. How many protractors are equivalent to 1 calculator? Protractors are something I remember way back from elementary school. Every time we had a back-to-school kit that we bought, there'd be at least one protractor in there. Haven't used one in ages, though. So I will write out these formulas in a way so that we have some variables here. I'll use CA for calculator, R for ruler, and CO for compasses. And what we want to figure out is 1 calculator is how many P. So I guess at the end we'll get a certain answer of P here for one CA. All right, let's keep going. So we know that it's 100 rulers according to the question. What I'm going to do is break up the 100 into 10 times 10, because 10R we know is 30 compasses. So plug that in, 30 CO, like that. This becomes 300 CO. And then I want 25, so I can break that up into 12 times 25 CO, like that. And if I do that, this 25 CO, I can put 50P. And there you go. 12 times 50 is 600. So 600P. So 1 calculator is 600 protractors. Therefore, number 12, the answer would be B. In the diagram, each of the 15 small squares is going to be colored. Any 2 squares that have a vertex in common or share a side must be a different color. What is the least number of colors needed? Okay, let's fill this out. So I'll start here. Let's make that red. Okay. Now the thing is, if a square shares the same side, it can't be the same color. It's got to be a different color. So this one, it's got to be a different color, so I'll put blue. And then similarly, this one has to be a different color. And then since this is red, this is a vertex right here. This side shares the same vertex, so it also has to be a different color. So that has to be yellow. So far I've got 4 colors already, just by following the rules of the question. So that means at least I'll eliminate A. Doesn't help too much, but let's just keep going here. This one I think can be red, right? Because it shares this side and it shares this vertex. So it can't be yellow or blue. And in a very similar way, you just kind of plug away at this. This can be green. And then I think this can be blue. This can be yellow. I just got to make sure that I can't put the same color in any other square that share the same side or vertex. So this can be red. This can be green. And let's complete this now. At the bottom, this can't be green or yellow, so I could put blue or I could put red. The next one over, it can't be red, it can't be green, and it can't be yellow. So obviously by process of elimination, it's got to be blue. This one over, I think the top and bottom rows will be the same because they will follow all the rules. And yeah, I think that's going to be like that. So basically, I just, there's no magic here or formula. You just have to plug away following the rules one at a time. And the goal is to use the least number of colors. And I did that. With just 4 colors, I was able to fill out the entire grid following the rules that no two squares that have the same side or share the same vertex are the same color. So I did it with 4, and I guess that's the minimum. So 13 is B. If x and y are positive integers, x plus y is 5, then a possible value for 2x minus y is. So we have x plus y is equal to 5, and we have 2x minus y. They want you to find the numerical value of that. So with this one, I will isolate 4x, and this will become x equals 5 minus y, and I'll substitute it into here. So 2 times 5 minus y. So this becomes 10 minus 2y minus y, which is 10 minus 3y. And we want to find a numerical value for this. So I guess you have to just start plugging in values of y. If y is 0, it becomes 10. That's not one of the answer choices. If y is 1, this becomes 7. If y is 2, it becomes 4. If y is 3, it becomes 1. Again, not one of the answer choices. If y is 4, this becomes minus 2. And minus 2 is one of the answer choices. So that's really what they're asking for, is what is one possible value for 2x minus y among the answer choices given. So 14 is D. In the diagram, square ABCD is made up of 36 squares, each with side length 1. The area of KLMN in square units is. So there's several approaches to this question. What I'm going to do is I'm going to find the total area and then subtract from it the side triangles. So this is a 6 by 6 grid, correct? So the total area would be 6 times 6. And then KLMN is basically the full area minus a bunch of triangles. And the first triangle is AKN. And the next one is KBL. And then LMC. And then NDM. Right? So it's these guys here. This triangle. This one. This one, and finally that one in the corner there. And each of these will have basically a base and a height that can easily be looked at with the grid. So this is 2, this is 4, this is 4, this is 2, this is 4, 2, 4, and 2. So all of these are actually 2 and 4. So KLMN is 6 times 6 minus, are they all the exact same? Yeah, they are. So 4 triangles that are exactly the same. All right, that makes it a little easy for us. So we got 36 minus 4. Each triangle is 1/2 base times height. Each has the same base and height, 4 and 2. So there you go. So you got 36 minus 4. 4 times 2 is 8. Divided by 2 is 4. And finally, you have 36 minus 16, which is 20. So the area of KLMN is 20, and therefore 15. The answer is D. If n is any integer, n plus 3, n minus 9, n minus 4, n plus 6, and n minus 1 are also integers. If n plus 3, n minus 9, n minus 4, n plus 6, and n minus 1 are arranged from smallest to largest, the integer in the middle is. Okay, several ways of doing this. You can either do it in terms of just the n's, Or, not that it's that difficult, but just give n a value. Whatever, I'll let it equal 10. So that means n plus 3 is equal to 13. N minus 9 would be equal to 1. N minus 4 would be equal to 6. N plus 6 would be 16. And n minus 1 would be equal to 9. So arranging this from smallest to largest would be n minus 9. And then n minus 4. Probably could have done this without the any value for n, but that's okay. And then n plus 3 and then n plus 6. Right? That's pretty much all they're asking. And then the middle one is n minus 1. So 16, the answer is E. In the diagram, AB is a straight line. The value of x is. Okay, so several approaches here. I'll just start here. The angles about a line are equal to 180. So this will basically be 40. Okay? And then the angles of the full triangle, as you know, add up to 180. So that means that these guys, 3y plus 59 plus this value that we just obtained of 40 is equal to 180. So 3y plus 99 is equal to 180, and therefore 3y is equal to 81, and therefore y is 27. So this is 27, this is 27, and that's 27. Now at this point, any way you want to proceed is fine. I'm just going to look at this triangle right here. The sum of the angles of that triangle are 180. 27 plus 27 plus 59 plus x is 180 equal to. So this looks like 180 is equal to 113 plus x, and subtracting 113 from the other side, you get x is equal to 67. So number 17, the answer is A. The average of a list n of numbers is 7. When the number in minus 11 is added to the list, the new average is 6. What is the value of n? So you've got a certain list here, and there's n numbers in that list. So we've got A plus B plus C and so on. Okay? And there's n numbers in that list. So if I'm going to figure out the average, I have to divide by n, right? Just like how you would figure out the average of any list. They tell you that average is 7. So that means that A plus B, if each of these letters represents a different member of that list, its sum is 7n. So that's the first part of the equation, of the question, I should say. Then what they're doing is they're taking that same list, A plus B plus C, and so on, and they add this negative 11 to it. And then they take the average, but this time you're not going to divide by n, you're going to divide by n plus 1 because we have one additional number now. And they tell you this new average is 6. And they want you to figure out the value of n. Okay? So A plus B plus C plus dot 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 minus 11 is equal to 6 times n plus 1, if I cross multiply like that. And then this A plus B plus C, I can, instead of writing it out every time, I can just substitute 7n, right? Because it's equal to 7n. So that's very helpful, I think. So this becomes 7n, all this stuff right here. And then of course I've got to keep that minus 11, and then I'll multiply this out, 6n plus 6. Okay, so far so good. And now this is simple algebra here. 7n minus 6n, 6 plus 11, and therefore n is equal to 17. And I think that's all they wanted, the value of n. Yeah, what is the value of n? So n is 17, therefore number 18, the answer is E. In the diagram, what is the area of quadrilateral ABCD? So I blew up the diagram and I drew one line in orange from A to C. And the good news in this diagram is giving you two right angles here. So that makes things very straightforward. Using Pythagoras, I will first calculate AC using 4 and 7. So 4 squared plus 7 squared is equal to AC squared. And therefore that's 16 plus 49 is equal to AC squared. So AC is the square root of 65. So square root of 65 goes right there. Now I need to figure out AD, the distance from here to here. So again, using Pythagoras, AD squared plus 1 squared is equal to 65 root all squared. Okay? And therefore, this means that AD squared is equal to 65 minus 1. AD squared is equal to 64, and therefore AD is equal to 8. And now, this quadrilateral basically is two triangles. In my diagram, I just divided them by this orange line. So the area of that quadrilateral will be the area of the two triangles added together. So the first triangle is 1/2 base times height, base and height. So we got 1 and 8. And then the second triangle, 1/2 base times height, base and height. So we got 7 and 4. So 8 over 2 is 4. 7 times 428 divided by 2 is 14. And therefore that is 18. So 19, the answer is C. The people of even land never use odd digits. Instead of counting 1, 2, 3, 4, 5, 6, an even lander counts 2, 4, 6, 8, 20, 22. What is an even lander's version of the integer 111? So first what I'll do is I will write some of the initial numbers here, and I'll come back to you. So what I've done in this list is I've just listed the numbers from 1 to 100 that they would use in even land. Now, you might be a little confused as to what exactly is the pattern here. What do they mean by this? Well, basically, all odd digits are never allowed. So 1 couldn't be used, 3 couldn't be used, 5, 7, 9. And similarly, you can't put 10 in there. Why? You might say, well, 10 is an even number. What's wrong with 10? No, because it has the digit 1. I think that might be the most confusing part. Similarly, you say, well, 12. How come 12 is not there? 12 is an even number. Yeah, because it contains the digit 1. So those digits can never be used, even if it creates an even number. So that I think that was the thing that confused most students. So only numbers that you can write are the ones that have even digits, I guess. So 2, 4, 6, and 8. That's it. And I guess 0. Is 0 an even number? Yeah, it is. Well, they put a 20 in there, so according to the question stem, 0 is allowed. So as you can see, I can't put any 30s, I can't put any 50s, 70s, 90s. So what I'm going to do first is count how many numbers was I allowed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 numbers. Okay? We got to get all the way up to 111. Okay, no problem. Now I'm going to concentrate on all the numbers from where? What's next? Can I go into the 100s? 101, 102? No, but I can't go anywhere in the 100s. All of those from 100 to 199 are not allowed. Why? Because all those contain the digit 1. So those are all out. The next set has got to be from 200 to 299. What I mean by that is the numbers I write are going to be in that range. They're not going to be up until 299. 299 obviously is not possible because 9 is an odd number. So here we go. I will write all the numbers that are allowed in this range. So this is the list. And in a very similar way, I was not allowed to use any odd digit. I couldn't put any number that had a 1 or a 3, 5, 7, or 9. So now this is how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 this time. All right, I purposely wrote them all out because I wanted you to see that it's 25 and not 24. So well, why? Wouldn't the pattern be exactly the same? Wouldn't it be 24 again? No, because look, you've got this is extra. Every other number is pretty much the same, like in terms of its, I guess, progression. But there's that one in the very first, because in this list up here, we don't have a 0, right? Because I'm just following their rules. They don't start with a 0, so I don't start with a 0. That's why there was only 24 there. And now at this point, you don't have to, fortunately, keep writing this all out. We can just do this with intuition or based on what we've already done. 300s, we can't use any number in the 300s because it's got a 3. 400s, we can. And very similar to this range, it will have 25 numbers. 500s we cannot use, 600s we can, and very similar, it will have 25 numbers allowed in even land. 700 we cannot use, right? Because it's got a 7. But 800, how many of those? 25. And I think by this point we have got into that 111 range. This right here, 24 plus 25 plus 25 plus 25, that gives you how many? Well, that gives us 99. We've got 99 numbers so far in even land. We want to figure out what is the 111th number. So now let's list the numbers in the 800s that are allowed in even land. So here we go. We got 800, 802, 804, 806, 808, 820, 822, 824, 826, 828, 840, 842, 844, 846, 848, and so on. I think we should be good by that point. So let's start counting here. Up until the 600s, we had 99 numbers that are allowed in even land. So once we get into the 800s, we get our 100th number, which is 800. This is our 101st number, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111. This is our 111th number. So there you go. 842 is the Evenlanders version of basically the 111th number allowed in this system. And that means 20. The answer is D.